Hi guys, welcome to Safi Mixed. In this video, I will talk about the symbolic representation of vectors. Symbolic representation is one of the different representations we use for vectors. And symbolic representation enables us to do vector algebra, vector calculus, or in other words, symbolic representation is the first step in understanding vector calculus or vector algebra. However, symbolic representation is not unique. We use different symbols for a physical quantity under different situations. And if you are writing a book or you are writing a report or certain article, the easy way to represent vectors is to use a letter in boldface. So that's very easy. If you are reading a book on physics and certain letter or symbols are written in bold, you should suddenly understand that the book is dealing with a vector quantity. However, if you are writing with pen on a paper or on a board like I'll be writing here, then we use a different approach to represent vectors. For example, I write 3 letters or alphabets and I put an arrowhead or semi-arrowhead on the first 2 letters. Then A and B, these 2 letters represent vectors. That is, we use a letter with a vector symbol over it or a vector with a semi-vector over it. Whenever one of these situations you see, whatever the situation may be, when we write a symbol, a letter with a semi-arrowhead or a vector over it, that quantity represents a vector quantity. On the other hand, if I look to see there is no vector, there is no semi-vector over it, then the C could represent any scalar physical quantity, or C could simply represent a number. So we differentiate numbers, scalars, and vectors symbolically by using a vector over the symbol or a semi-vector over the symbol. But such representations are general. The symbol A and B could represent any physical quantity or any vector quantity. However, when we are specifying the nature of the quantity, then we shift from generalized symbolic representation to certain special symbols. For example, if the physical quantity we are dealing with is force, then there is a special symbol and we write the force with a letter F with a semi-arrowhead over it. However, this F is not unique. We change the symbol for force if we know about the source of force. For example, if the source of force is gravity, then that force is called weight. And the symbol for weight we use is usually small w with an arrowhead or semi-arrowhead over it. Now, if we are dealing with several weights or several bodies are involved in our problem or in our model, we then add additional information to distinguish between the weights of the bodies. And for example, we add W with an M, where M would represent weight of a man. And we write W with a W and the subscript. So the subscript with a symbol or with a letter of vectors provides further information. For example, the W sub W may represent the weight of a woman. You use other symbols like I can write W1 and W2 for the weight of man and for the weight of woman. Similarly, if the source of force is a thread, that is, one body or one machine is exerting a force via thread, via chain, or via a rope on another body, then that force we call tension. And for tension, we use a symbol T with an arrowhead over it. You see now, we are shifting from F to W when the source of force is gravity. And we are shifting from F to T when the source of force is a rope. And if we are dealing with multiple tension, then again we add additional information with the subscript like T sub 1, T sub 2, and T sub 3 to represent different tensions. Similarly, if the source of force is friction, then for that force, we use another special symbol, and that is usually small f with an arrowhead over it. And if we are dealing with multiple fractions, then we add further information in the form of subscript, and in general, we write this as f sub I, where I could be a number or a name or anything else. But that I would provide special information about a special situation. And if the force is arising from the motion of a body and fluid such as air or liquid, then that force we call usually drag. And the drag force is represented with F, capital or small, with a subscript D or drag. So I can write it drag or D. Again, you see, when the source of force is known to us, we are shifting from capital F to different symbolic representation of the force. And we use another symbol for force, which is normal force. Normal means a force that is rising from one surface over another body, and we represent this with either capital N or capital R. So when the source of force is changing, we accordingly change the representation, the symbol or the letter for representing that force. And if any of these forces is causing the body to travel in a circular path, then we call that centripetal force by representing it with a subscript CP. F with a CP means centripetal force. So that centripetal force further specify another scenario. For example, the weight or the gravitational force turns the moon to move in elliptical orbit, so the centripetal force in that case is gravitational force. And if you tie a ball to a thread and wire it in a circle, then in that case the tension is centripetal force. Similarly, when you are traveling on your bicycle, on car or motorcycles in a curved path, in that case the friction is responsible for providing the centripetal force. So the symbolic representation for a physical quantity is not unique. Rather, we change the symbol to represent the particular scenario with different symbols. And this is not only limited to force. For example, if you are dealing with acceleration, then the generalized notation for acceleration is A. However, if the acceleration is due to circular motion, we call that centripetal acceleration by adding the subscript ACP. We use another notation AT to represent tangential acceleration. And there is a special symbol that represents the acceleration due to gravity. We represent that with small g. And similarly, if the body is moving around or the body is rotating, then in that case we have another symbol alpha to represent angular acceleration. So the symbolic representation for a given physical quantity is not unique. Rather, the symbol changes as per the description of the scenario or as per the description of the model. And it is not only limited to force or acceleration. We use different symbols according to the scenario, according to the situation for different physical quantities. So that's enough for symbolic representation. If you haven't subscribed to Safi Mix, kindly support the channel by pressing the subscribe button on the video. And if you like the video, don't forget to hit the like button as well. Thanks for watching.